Hello friends, welcome to civil engineering exam. Today we are going to see the problem related with design of reinforced concrete elements in the topic of simply supported roof slab spanning one direction. Okay, so that is roof slab spanning one direction, that is one way slab. So now the given data. So the clear span is 4 meter, then support on the load bearing wall 40 centimeter thickness. Okay, the support will be 40 centimeter thickness. Then materials ribbed tar steel is used, then M150, that is FCK is 150 kilogram per centimeter square. So then allowable stresses are given, that is C equal to 50 kg per centimeter square, QS equal to 5 kg per centimeter square, QB is 14 kilogram per centimeter square, then T equal to 2300 kg per centimeter square, then A equal to 0.903 effective depth, R equal to 6.95. okay, so now we can use the IS 456, then IS 875. okay, so these codes are we can use for find out the area of the reinforcement. okay, so now first thing we have to find out the depth of slab. For simply supported slab in one direction, there is one way slab, so D equal to span by 30. okay, so span by 30, the span is 400, that is 4 meter, that is 400 centimeter divided by 30. okay, so now we got the value of 13.5 centimeter. okay, so now we can take D is equal to 15 centimeter. okay, so we can round off the value, so D equal to 15 centimeter. so next thing is effective depth, so use 12 mm dia bars. So now the effective depth will be DE equal to 15 minus cover plus half the dia. okay, dia of the bars. So now the 15 minus the cover is 1.3 centimeter plus 1.2 divided by 2. okay, so the 1.2 is the diameter of the reinforcement, so 12 mm, that is 1.2 centimeter. okay, so now we got the value of 13.1, that is equal to 13 centimeter. okay, so 13 centimeter is the effective depth and 15 centimeter is the overall depth. okay, so now we can find out the span. So now the effective span, so the least of three things, that is center to center of the supports. So center to center of the support, so center to center of the support, that is 4 meters clear span plus, so 0.4 divided by 2 plus 0.4 divided by 2. okay, so now we got the value of 4.4 meter. okay, so 4.4 meter. so then clear span plus width of the support, that is clear span plus width of the support also 0.4, that is equal to 4.4. okay, so next thing is the clear span plus effective depth. so the clear span is 4 meter plus effective depth is 0.13. okay, so now we got the value of 4.13 meter. okay, so we have to take the effective span, the least of the three things. so now the least value is 4.13, so now effective span will be 4.13. okay, so next thing is we have to calculate the load. so load calculation, so now the live load on accessible roofs is 150, so the live load equal to 150 kg per meter square. so then dead load, so now dead load equal to, the slab is 15 centimeter. okay, so now the 15 into 1 into 2400 is the unit weight of concrete divided by 100. okay, so that is equal to 360 kg per meter square. okay, so now roof finish and floor finish, so we can take the value of finish, we can take the load of 3 kg per meter square. so now the total load will be total load equal to 513 kg per meter square. Okay, so now we can take 515, so we can round off the value, so 515 kg per meter square. So this is a W load value. Okay, so next thing is we can find out the bending moment. So the bending moment, the formula will be M equal to W L square by 8. So that is for simply supported beam, we can take the W L square by 8. So W will be 515 into length is 4.13 square divided by 8. Okay, so now we got the value of 1090 kg meter. Okay, so next thing is shear force. So shear force S equal to WL by 2. So now we can substitute 515 into 4.13 divided by 2. So now we got the value of 1060 kg. Okay, so this is the bending moment, so this is the shear force. Okay, so now we can find out the effective depth required. So now depth required DE equal to root of M divided by B into R. Okay, so now we can substitute the values. So moment equal to 1090 into 100 divided by B is 100 into R values, that is given 6.59. So now we got the value of 12.9 centimeter. Okay, so now DE is 12.9 centimeter, so we provide 13 centimeter. Okay, so now hence it's a save. So now we have to find out the main reinforcement. Okay, so now main reinforcement, main steel. So now the AST equal to 1090 into 100 divided by 2300 into, so A value, so that is 0.903 into 13. Okay, so now we got the value of 4.01 centimeter square. Okay, so use 12 mm dia bars. So at spacing of 29 centimeter center to center. Okay, so now next thing is secondary reinforcement, secondary steel. So now hence the AST equal to 0.15 into 100 into 1090 divided by 100, that is equal to 2.25 centimeter square. Okay, so now use 8 mm dia bars at 22 mm center to center. Okay, so next thing is we can find out the shear stress value. So shear stress, so shear stress equal to QS equal to S divided by B into A. Okay, so now we can substitute 1060 divided by 100 into 0.903 into 13, that is equal to 0.905 kg per centimeter square. So that is less than of 5 kg per centimeter square. Okay, so hence it's a safe. So this is a method we can solve the problem. Again, we'll see next video. Thank you.